Imagine a single dam so powerful that it could power the entire United Kingdom, every home, hospital and factory. That is China's brand new mega dam in Tibet. It is said to be the largest hydropower project on planet Earth. It promises clean energy on an unprecedented scale. But it could also spark the next water crisis for Bangladesh and India. In the next 8 minutes, we are going to take a look into the awe-inspiring engineering behind this dam and uncover its hidden risks. And we are going to ask ourselves, is mega-scale the future of clean energy or a gamble our planet can't afford? Welcome to Yarlung Tsongkhapa Canyon in Tibet, one of the most remote and rugged frontiers on Earth. Here, China is planning to carve out a dam with a mind-blowing capacity of 60 gigawatts. Let's put that into perspective. That's about the same power the entire United Kingdom uses, and nearly 3 times as much as the Three Gorge Dam, the current record holder, can provide. To achieve this, engineers will divert a river down a 2,000-meter drop through 5 cascading power stations, all carved into the mountainside. We're talking tunnels longer than Paris is wide, spinning turbines the size of skyscrapers. At peak flow, this single dam could power more electricity in a single hour than most countries are going to use in a single day. But pulling that off means years of tunneling through solid rock at 3,000 meters elevation in brutal cold and thin air, while pouring millions of cubic meters of concrete and coordinating tens of thousands of workers. This is adding to an estimated price tag of $150 billion. Harnessing this extreme elevation is what is going to make this dam so powerful. But those same conditions are what is going to make building here one of the most difficult engineering challenges in the world. So, why is China wagering so much on this bet? And what do they hope to gain beyond sheer power? So, what's driving this colossal gamble in the high Himalayas? Well, let's start with the basics. China needs massive clean energy capacity to hit its carbon neutral target by 2060. Over half of China's electricity still comes from coal. This one project alone could offset tens of millions of tons of emissions each year, replacing nearly 50 coal-powered plants. Second, they want to achieve energy security and power grid stability. Hydropower is dependable in ways clean energy isn't, like we have talked about before. By harnessing the headwaters here, China can smooth out the unpredictable peaks and dips from renewables and deliver a steady flow of electricity to its booming eastern cities. And third, they want to develop this region. This remote corner of Tibet, Medoc County, has been one of China's poorest and least accessible regions. This single dam will bring highways, bridges, and rail lines through the mountains, linking communities that have been isolated for centuries. Thousands of jobs will follow, from tunneling crews and dam engineers to grid technicians, along with an estimated $150 billion local investment. To Beijing, this isn't just a power station, it's a launchpad for transforming an entire region. But can all that progress come without a cost? What environmental and social risks could make or break this mega dam? For all its promise, this project sits in one of the most geologically unstable regions on Earth. The Yarlung Tsongkhapa Canyon lies in a high seismic zone. Earthquakes and massive landslides aren't rare here, and a dam failure on this scale could be catastrophic downstream, and it can create a man-made disaster on a scale never seen before. There's also the impact on its people. Entire villages may be relocated to make room for construction, repeating the story of the Three Gorge Dam, where over 1 million people were displaced. Then there's the ecosystem. This canyon cuts through one of the most biodiverse corners of the Himalayas, home to rare plants, migratory fish and endangered species like the snow leopard. Altering the river flow here could disrupt habitats that took millennia to form. Critics argue that megadams like this often trade one environmental crisis for another, cutting carbon emissions while damaging rivers and communities beyond repair. And that is where the stakes rise even higher. The river doesn't stop at Tibet, it flows straight into India and Bangladesh, nations that are already anxious about water shortage. Could China's quest for clean energy create the next water conflict? Let's follow the river downstream. All that electricity comes from one thing: controlling Asia's mightiest river, one that doesn't stop at China's borders. The Yarlung Tsangpo becomes the Brahmaputra as it thunders into India's Arunachala Pradesh, and it flows through Assam and spreads across the lowlands of Bangladesh. For hundreds of millions of people, this river means life itself, watering crops, replenishing fisheries, and providing drink water during scorching dry seasons. But a macadam upstream can change everything. It can hold back the sediment that fertilize the farms, shift the timing of flows, and even risk severe water shortage when demand is already soaring. And a single mistake here could cost these people everything. With climate change already pushing droughts longer and populations growing, any disruption could ignite real tension between China, India, and Bangladesh. Both India and Bangladesh have already protested, demanding transparency and shared river data to avoid a crisis and ensure the future of their water. Now, for a moment, let's take a step back and ask ourselves, are megadams like this truly the best way to power our future? Or are we trading one crisis for another? Let me know what you think in the comments. Could this be the start of water wars, or is it a necessary leap for clean energy? Megadams like this raise a question. Are they the future of clean energy, or a relic of an older way of thinking? To match this dam's output, you would need over 3,000 large wind turbines, or a solar farm bigger than London. And solar and wind are cleaner to build and less disruptive, but they are unpredictable. The lights still need to stay on when the sun and wind disappear. That's why some nations still turn to dams, despite the risks they pose. They don't just generate electricity, they act like giant batteries, storing energy and stabilizing the grid when other renewables fluctuate. But our future may not belong to one solution. With grid-scale batteries, pumped hydro systems and smarter energy networks emerging, the real answer could be a mix, balancing scale, reliability and sustainability. Would you trust a single macadam to power your future, or would you rather see a web of smaller, flexible renewables? Personally, I think we need to combine them to truly get the best of both worlds. Tell me what you think in the comments below. I'm curious where you stand. And if you want to explore more ways we can build a sustainable tomorrow, check out this video right here. I'm sure you will find it interesting. Remember, together we can engineer a sustainable tomorrow. Don't forget to subscribe so we can build a sustainable tomorrow together. Thank you for watching and I will see you in the next video.